So here is another debugging demo with the fourth bug from the Lang project downloaded from defects4j database. All right, so let's, as usual, run the tests and see what we have to work with. All right, there we go. We have one failure. So if we go there, okay, so there's a cert equals, and now there's a value. So we have a result, and the result should be 3. Now, again, before we start investigating, we would like to know what is the observed compared to what is expected. So we're expecting 3, what comes, obviously, it is something else came. Okay, so here actually, this is nice because with the equality, it gives you some information. So here it says, so this is the message that is written here, but we expected 3, but what returned actually 0. Okay, so if your tool doesn't give you this information, you know how to figure it out. Like you can run it in debug mode and then see what the value is in the while it's running, right? Like we did in the previous demo. But now we know, okay, so we can skip this step because we already know that it is a 0. So why is it a 0? Now it is calculated here. So this is the line that we need to look into. Okay, so let's put a breakpoint here and run this case in debug mode. All right, so what is it that we have here? We have something of type lookup translator. So an object of lookup translator that we create here, and then we call the function translate, and then we give it a value, and so 3 values. So now let's get inside and see what is actually going on and try to understand what is supposed to happen and why it didn't. So if we step inside, all right, so we know this function is supposed to return 3. So, and it returns 0. Okay, so it's either returning 0 from this line, so it has skipped all this loop altogether, or in the loop there was a value of 0 somehow that was returned. Okay, so let's see. Well, this is, if there is a value other than 0, it has to come from here, right? So let's see if this line is ever executed. So let me continue. There's a breakpoint in that line to see whether it would be executed. So let's continue. So the execution finished and this line was not executed. So that 0 was not returning from here. It was returning from here. Okay, so that loop. I don't know if it was not executed altogether or if it was executed, but it didn't. This block was not run, like was not executed because of the guarding condition. So let's put a breakpoint here. I will disable it for a bit just to make sure that we investigate the proper call, because obviously this might be called multiple places, as we can see here. All right, so let's rerun this in debug mode. And let's step inside. Okay, now let me enable that breakpoint and jump to it. Yes, so the loop was executed. So this is the first iteration, but let's see why was this. Okay, so obviously this condition, I mean this block would be only executed if the result is not null, and obviously it is null. Okay, so the value that we want depends on the value of I and also depends on the value of result, right? So the value of I itself, because it is the value that's returning, and we want it to be 3. And it is actually 3 on the first iteration. Okay, so that seems to be correct. So this data dependency seems to be correct. The reason I'm saying it seems to be correct is that this is a loop. So in the loop, the iterative nature of the loop means that the value of I may change. No, it is possible that it is correct that the value is 3 at the first iteration and it should return at the first iteration. Or it could be, it is possible that it could be something higher than 3, and then because this loop is decreasing, the first iteration should be something higher than 3, and then it should return after a couple of iterations. But for now, it seems to be correct. So let's assume that this is the value that we want. If it turned out that the result is not the reason, the problem is not in the value of result, then we would look into that. Okay, we have to take it piece by piece. But okay, here is a possible value that we want to return at the first iteration. Now the other dependency here, in order for us to get this value, is on the result. So this is a control dependency. Now we want result to be not null. Okay, now result depends on this line. So in this expression, this expression has 2 data elements and then 1 operation. So the data element, there is a lookup map, which is a hash map. All right, and the subsequence, which is the value calculated here. So now the logic, the part of the program logic that we need to understand is becoming more apparent here while we are working, right? Now we may not know what exactly this lookup translator is supposed to do because we are suspending the program logic, but we know that this is a hash map, and we know in Java hash maps is a data structure that is supposed to have entries of keys and values, right? And the get operation is a function in the hash map that takes the key and supposed to return the value equivalent to that key or the value associated to that key. Okay, so here what we are doing is that we can figure out, like we can understand that we are receiving a key. So this translate function takes a key and tries to get the value associated to that key in the lookup map. So this lookup map is created or constructed or built in the constructor. Okay, so this is one dependency here. And then this, the key is coming from the input. Okay, so the subsequence of the input. Now the input is coming in as the argument from the test case. So let's assume that right now that we are sending, so this is coming from outside. Okay, it is always possible that the value coming from outside is wrong, but since this is coming from a test case, let's start with the assumption that the values coming from outside are correct. So this is coming from outside, so right now we're not going to look into it. We assume it's correct. And then index is also coming from outside. And then there's the I that we also assuming is correct for now. So let's say we have a subsequent key. And we're trying to figure out the value associated to this key that's supposed to come as a result. Okay. So since this is mostly this is the value assumed correct for now. We need to look into this hash map. So there we are sending a key of 1, so the key value is 1. Why is it not returning the value associated? It looks like the key 1 exists. Okay, so maybe we need to look in more detail. So let's take this into the expression so that we can have more room to look into it. So I'll take this to watch. All right, so here is the map, the key, and then there is the value of the key is, oh, look at that. So the first 3 characters are correct. So the value is 1. We make it look like that it is the correct value when we look at it in the inspection window here. But there are extra invisible characters. Obviously, now if we look at the value that we are sending, does it also have these invisible characters? So let's have a look at that. No. So this is a string that has 3 characters, and this one has, even though it looks like it has 3, count as 3 here, it has actually 18 characters. Or 19 characters. Okay, so it seems that there is a problem in the construction of the lookup map. All right, so that's a good discovery. There is a problem here. This is dependent on these lines inside the constructor. Okay, so we need to step inside the constructor to look into what is happening there. Okay, so let me start this, go back to this case, and we need to look at this line because this is where the constructor is called. All right, so I'll move this. Now let's rerun that. Debug as JUnit test. Okay, so let's see. I'm just gonna remove these for clarity. Let's see what is happening here. So we are sending a 2-dimensional array of character sequence that has 1 entry, and because it's a 2-dimensional array, so the first entry has 2 entries in it. So 1, so this is the value that we're looking into. And it is supposed to have an associated value of 2. Okay, so let's step inside to see how does this map gets constructed. Okay, so those values are received here in that lookup. Okay, and all what we do here is that it just, let me step inside it a couple of lines. So it loops over that lookup, the list of arguments coming here, and just put them one by one. Okay. So I just want to see. Well, it doesn't seem to be a lot of logic here, so I'm not sure why. Would that be a problem? I just want to see what's inside the argument. So I'm just going to send it to the watch as an expression. Okay, so here. So yeah, we are sending a 2-dimensional array that is correct. It has 1 element, and that element has 2 internal elements of string buffer data type. That's what we did observe here. Okay, so let's see what are the values. Count is 3. Uh-oh. Here are the invisible characters. We didn't do anything yet in the constructor, so something happened between the execution of the constructor and the sending of the arguments. Okay, so let's stop that and investigate that particular step. So something happens. It seems like there's some logic happening inside the round parentheses of the function call before it actually goes to the inside the constructor. So let's investigate that. So what we see here is that it just creates an object. Okay, and that's something from the standard library. And inside that, it creates 2 objects. So all that, now that is our code. These are standard libraries. Well, it doesn't mean, just because it's from the standard library, it doesn't mean it's guaranteed correct. Now let's rerun it in debug mode and see what is happening here. So we're just sending a string to the constructor of the string buffer. Let me see. What does that look like if it was evaluated on its own? All right, so let me see. Oh, I see. So it's coming, the constructor returns a value that has invisible characters in it. So that is where the problem, that class adds additional invisible characters to the string that we sent. All right, so I can claim that the root cause of the problem is right here in the use of the string buffer. Okay, and actually if we look at this case was successful. So, and it doesn't use a string buffer, it uses just a natural string. So it seems like we found what we're looking for. Here is the root cause of the problem, that string buffer is adding additional invisible characters. So let's have a look at what they did. How did they deal with this problem actually? Okay, so this is the code that we are looking at. So the hash map, instead of having character sequence, they took string right away. So they changed the data type of the hash, the key of the hash map to a string instead of character sequence. Okay, and then here when they created the entry for the hash map, they call the toString. All right, so it seems like the toString removes the additional invisible characters. Let me just, out of curiosity, I just want to verify that. So I'm just gonna run this here. I want to see if I call toString. And we look into that. Yeah, that is the problem. All right. Okay, so we did find the 4th bug. Congratulations. Thank you very much for watching.